So my next example that I want to talk about is a little bit different grade level. This is a kindergarten example. Take a moment to think to yourself, how will students respond with a pretty straightforward question? How many flowers are there? What do you think students would say to this? These are kindergarten students at the beginning of the year. So I'll give you maybe 5 seconds of think time before we unpack how students thought about it. Yes, yes, I see some correct answers. I see some number inversion. Oh, I love that. Okay, great. Okay, so I say this all the time, and I really do mean it. When we allow for open-ended response, we can enable students to surprise and delight us, and they do. And for anybody who's taught kindergarten, they know that creativity and innovation always finds a way if you give an outlet. And so let's see how our students responded. But before we get into that data, oh, I love one type of flower, Joshua. That's great. We actually did see that in our data. I just want to highlight that instead of our four predetermined responses, A, B, C, D, with just a relatively small data set, I know 1,400 students feels large, but for us, it's pretty small. We had 166 unique student responses. So we had students like our people in our chat that put 6 and 6, and we had people who put different responses. We had 166 ways that students express themselves when thinking about this concept. So that's so it's just so rich for us to uncover. So we have 69% correctness, but we also have this 166 different ways of thinking in this data set that we can uncover and explore. So let's talk about it. So here are some of our top student responses that we saw from this field study trial. And as you can see, Charlotte is representing our correctness, and that is interesting and engaging. Um, Lily is showing us that we have somebody who is very, and this is very common, if we're at the beginning of the year for kindergarten, if we situate ourselves, who's showing us accounting strategy and probably likely exhibiting accounting fluency error. This makes sense. We're still learning our numbers from 1 to 10. So for Lily, we can see that there's a lot to build off of here, and that we need to practice our fluency so we can use skills and tools at our tool belt for Lily that will feel different than our strategies that we might have for somebody like Javi or Ezra. And I really like talking about Javi and Ezra because we saw these in a percentage of our students. And what Javi and Ezra are doing here, what we likely think, because we never know for certain, but we get data and that can support our suppositions about how students are thinking, is that they are exhibiting an accounting strategy. So imagine Ezra is counting these flowers as he's looking at the screen, and he's marking them down with essentially what is a tally mark, right? So we have 1, 2, 3, 4, 5, 6 tally marks that are all represented by the number 1 for Ezra. So we see an effective counting strategy, but we don't see a total. That's different from Lily and something that we would celebrate in a different way and build off in a different way. And same thing for Javi, where we see a counting strategy, but different from Ezra, he's keeping track and he's increasing his counting. So it was actually very interesting for us. We had a very, very heated debate. We were very passionate about student thinking here of is Javi giving us an effective counting strategy, and is he also giving us a total? Or is he, like we see kindergarten students, counting 1, 2, 3, 4, 5, 6, and not really making sense of the fact that that's answering the question of how many flowers are there? So this is just eliciting so many good questions for us and so many opportunities to dive into our data in a way that we wouldn't have if we had given these answers to these students ahead of time. So this is my kindergarten example. And now what I'd like to do is I'd like to pivot to a slightly different example of a grade 2. So this is our grade 2 students at the beginning of the year. And here we have some data that's organized. And as you can see, it is open response, right? So hopefully this is starting to become clear. We're flexing that muscle a little bit more of what we mean by asset-based, and that hinges upon being able to collect more data from students, and that starts with an open response. What I want to uncover with this example is that when we looked at this, we had really interesting data. So let's talk about our top correct answers here. Um, the question that was asked was how many more students voted for fish than hamster? So we saw five, which we think is students giving us the number of fish. We also saw students give us six, which is our number of bunnies, right? These are assets. These are things that students are seeing. We also see 14 for the total number of votes, students counting and making sense of this table. And then we see three hamsters. So these are our top incorrect answers. We had students, of course, who got this correct, but for the purposes of our conversation today, I want to focus on this because what this is telling us is that we have a lot of sense making that's happening for this item. We are just answering a different question than the one that's being asked. So that is something that as teachers, as administrators, we can lean into the fact that we see mathematical thinking. It is evident in the way that students are thinking about the data and the questions that they are asking. And that informs our next steps. So instead of going back and reteaching this skill of how to look at data that's organized in tables, we perhaps would do something a little more nuanced or a little bit more targeted to the types of errors that we're seeing students make, like a sense making routine.